Well, hello, folks. Thanks so much for joining. This is my first ever live stream on my YouTube channel, and I'm joined by none other than Mike Flannigan. He's a wildfire expert and professor at Thompson Rivers University. We've collaborated a lot in the past, so thanks a lot. It's good to have you on, Mike.
Great to be with you, Kyle.
Right on. So, what we're going to do this evening is, given that it is the first ever live stream, hopefully there's no technical glitches. I think it should be going pretty good, though. And we're going to talk a little bit about the wildfire situation in Canada, probably 15, 20 minutes or so. And if you have any questions that you start to think of during the presentation, feel free to throw those in the chat. And then we'll have a Q&A at the end, as long as it takes to engage with your questions. So, if you have questions, feel free to throw them in the chat. But with that, let's get straight into the presentation here. The first thing we're going to look at here is the map of active wildfires across Canada from CIFC. And basically, the reds and the purples are our fires that are out of control. I'll get Mike to explain just in a moment here what the difference is between the purple and the red there. But take a look down here in the bottom corner, 8.8 million hectares burned so far this year. That's an incredible amount, and we'll see just how incredible compared to normal and other recent years. But Mike, what are we looking at here between the red and the purple on this map?
So the purple are monitored fires. Basically, they're watching, but there are no suppression activities. Whereas the red, there is suppression activities, whether it's modified or full suppression. And, there are about 370, 380 of those out of control purples and reds. So there's still a lot of fire in the landscape in September. And 8.8 million hectares. To put that in context, that's the size of New Brunswick. Plus, I'll throw in a couple PEIs in there to get to 8.8 million. And you can see most of it's been concentrated from northwestern Ontario through the Prairie Provinces, BC, Northwest Territories, Yukon. But there's been a smattering in the east. And it was in the summer, which is a bit strange for New Brunswick and Nova Scotia, which is typically a spring-fall fire season. But I have to give credit to Nova Scotia and New Brunswick for being proactive and restricting access to the forest, because they were getting human-caused fires. And by restricting the access, it really does help prevent human-caused fires.
Yeah, definitely. And for what's going on right now across the landscape here from the Natural Resources Canada website, we can see that the East is really kind of quieted down in a big way, but we still have smatterings of action across the West. Northwest Saskatchewan coming back to life there. Parts of the Northwest Territories, including areas especially west of Great Slave Lake there, where we do also have some evacuations. And of course, this other cluster here in the Caribou-Chilcotin region, sort of west central BC there on the plateau. Several fires there with some evacuations as well. We look south of the border as well. We've got some fires in the inland Pacific Northwest. And all of these fires together are sort of conspiring to reduce our air quality across Western Canada. So we are seeing some fairly significant reductions in air quality. Again, these are just hotspots based on satellites. And if we take a look here now at the cumulative area burned based on satellite hotspots here, what we're looking at in this graph is your normal is this sort of light gray line down here based on the average of 2003 to 2024. And the last 3 years have been well above average. This is 2024, this red line here. 2023, of course, just absolutely unprecedented fire season there that just continued to go right into late September with actually the biggest burning period of the entire month, the entire season happening toward the end of September. And then, of course, 2025 here, we're still kind of slowly trucking along here with, over 8 million hectares burned now. So second worst in terms of area burned on record, right, Mike?
Yeah. And, when I first started in this business quite a while ago, September was really a quiet month. I mean, maybe 4 or 5% of the total area burned happened in September. But the last few years, and especially as you pointed out, end of September, the biggest one-day jump in our modern-day record, it was because of pyro CBs, fire-generated thunderstorms in northeastern BC, northern Alberta, and southern Northwest Territories. And it used to be that September came along, Yukon, NWT, fire season was over. Not anymore. That's one of the signs of climate change, is a longer fire season.
And as we'll see in a little bit here, that we are still seeing conducive fire weather conditions for more spread in the month of September. This kind of reminds me, Mike, as well of just an odd similarity with the Chinchaga firestorm, a very similar area of northwestern Alberta, right around the same time of September. Massive area burn generated a pall of smoke that traveled across the country, darkening skies, making the moon look purple and blue. Really odd similarity there. So, I mean, given the warm, dry weather that we're still seeing, is it possible that we might see another, significant wind-driven or convectively driven fire spread day in the future this month?
Absolutely, and we're going to talk a little bit more about that later on. And if Corey Teamster was on the call, we could talk to him about the Chinchaga fire because he wrote a book about the Chinchaga fire.
Yeah, definitely. That was a good book. I remember reading that myself. So area burned by province, how that breaks down, it's pretty remarkable. When we look here, the lion's share of that area burn is really shared between Saskatchewan and Manitoba there, with like over half of that nearly 9 million hectares coming from those two provinces, right?
Yeah, and I believe for Saskatchewan, this is a record-breaking year. For Manitoba, 1989 had over 3.2 million hectares, and this year it's 2.15 million hectares. So I don't think we'll beat that record, but it was a very active year in Manitoba. Some deaths, unfortunately, early on, and Saskatchewan just has been burning and burning and continues to burn as we speak.
Yeah, absolutely. And that fire season, like you say, began in May, and it just kind of burned all the way through till August. And we did have a couple of heavy rain events across northern parts of Saskatchewan, northwest Manitoba, that kind of slowed things down for us there. But as we see, northwestern parts of Saskatchewan are starting to come to life again. To put into perspective, though, why this wildfire season has been so intense across much of Canada once again this year, this is our 90-day precipitation anomaly. So precipitation relative to normal over the past 90 days. These reds are where it's really dry. We're getting less than 125 millimeters. A lot of areas of Canada actually saw less than half the annual or the average precipitation for the 3-month period over this time. So you can just imagine how much that contributes to drought and the potential for fire spread. These fires can really burn deeper. They can burn more intense with that worsening drought. We do have a couple notable kind of exceptions here. Southeastern BC interior, southern Alberta, southwest Saskatchewan really saved our water resources and growing season in that part of the world. And of course, across, Lake Superior, northern Ontario, northeast Ontario. But I mean, most of the country very dry. And as a result of that, if we take a look at our, drought monitor map of North America, we are seeing expanding drought across much of Canada. And actually, this is from July 31st. It's going to look similar, if not worse, in some areas for the August update, which is going to come out in a few days here. But widespread drought across much of western, central Canada and the western half of the United States. Kind of reminds me of 2021 in many ways, and with that notable exception there in parts of southern Alberta. But drought, of course, is a major player in these wildfire seasons, right, Mike?
Yeah, it is. And if you look at where our area burned has occurred this fire season and where the more severe drought is, it's a pretty good fit.
For sure. Temperatures as well this past summer, actually pretty close to normal across fairly large areas of Canada. Some exceptions out there in Atlantic Canada and across much of the West. Very warm. But what we've seen in recent days, actually fairly significant temperature records broken. In Ashcroft, BC, September 3rd, I believe it was, near Cache Creek there, they hit 40.8. That shattered a provincial September all-time high temperature record, and it was also the national September high temperature record now. So, and as well, I think September 4th in Yukon, they broke their territorial record, temperatures of around 29 degrees. So that's just obscenely warm for the time of the year there. And, that's certainly playing a role in this sort of near-term fire danger we've been seeing in Western Canada, right?
Yeah, that's where the upper ridge has been sitting. And it was quite a persistent upper ridge. It lasted for weeks, and it's still sort of hanging around. It doesn't completely want to go. It's going to shift to the east for our friends in Alberta.
For sure. Let's take a look at the satellite imagery from this evening here. Basically, what you're looking at is sort of like a true color image of basically Western Canada, the Northwest states there. And we've got the fire temperature RGB, just another project overlaid on top, overlaid on top of that. That shows us kind of where our hotspots are actively this evening. And we can see, you may be able to see there on your screen that those fires in west central BC puffing this evening, giving off some more smoke, burning pretty hot, one of those fires there. And we also have a couple down there in Washington. And we can also see sort of that diurnal thunderstorm activity popping up here. We have a little bit of a buffering issue with this site. It's it's a lot of data, but you get the picture. Southern BC interior, these mountain ranges, these ridges really light up with afternoon thunderstorm activity. Pretty late in the season to be seeing this type of action, right, Mike?
Yeah, though, as I mentioned, September seems to be the new August. So can we zoom in a bit on the Caribou Chilcotin? Yeah, just yeah, there you can see the hot spots a little bit better. And that smoke really knocked down our temperatures in BC and maybe knocked down some of the thunderstorms we might have seen and the lightning we might have seen. Um, but earlier I was looking at this image and there was a lot more hot spots, but as the cloud and smoke moves north, it does block the signal. And that's where, this site was actually down this weekend and I was lost because, I use Firms, but Firms isn't real time. This is real time. And so it's nice to see. And yeah, there's fires burning as we speak, evacuations as you've mentioned.
For sure. And continuing to see that sort of diurnal thunderstorm activity. And we'll look at why that's happening in just a moment. We'll take a look at the air quality via Purple Air. This is a great tool if you're not familiar with it. You can kind of get a sense once it loads here where the how the air quality is doing. And notable difference across northern Midwest, eastern Canada, Great Lakes region. Nice clear air out there right now. All the poor air quality is kind of focused in western Canada and the northwest states there, close to the fires. We've got this constellation of fires around western Canada, reducing air quality. I've certainly seen it worse than this. But given the stagnant upper air pattern that we're seeing with that upper ridge really persisting in recent days and in the days to come, you tend to see sinking air on the large scale. You see weak winds at the surface. That doesn't tend to push that smoke away very quickly and just sits there and it's stale, stagnant smoke. And especially in those valley bottoms in BC, it can just really get trapped in there.
Yep, I live in a valley and I know exactly what you mean. And you see satellite pictures, and when there's no cloud and the smoke's just trapped in the valley, and that's where the people are.
Absolutely. And Kamloops, they're kind of at that confluence of valleys there. It is a pretty bad area typically when there's fires burning nearby. It looks like it's improved a little bit in parts of Washington there. There was quite a bit of purple there over the last few days. But nonetheless, smoke season here. And of course, if we actually play, this is a great product from Environment and Climate Change Canada. This is firework. You can get out to, well, about almost 3 days. Taking a look at the smoke, how it's going to spread over the coming days, you can just see how stagnant that is. It's really just hanging out there in BC. And, we got sources of smoke in several different areas, just kind of conspiring to reduce air quality across the region. And as Mike said, what can happen with this smoke is it can actually really reduce the daytime temperatures and, risk of thunderstorms as a result of that. And weather models don't ingest smoke information, basically the data from how you say you got a smoke plume moving along, and it's not as a part of the weather model output. The model's just going to say, oh, based on these conditions, your high is going to be about 30 degrees today, and then it ends up being like 5 or 10 degrees less if it's a really thick pall of smoke, because it's just basically that incoming solar radiation is reflecting directly off the smoke back out to space, and you're not absorbing that heat at the surface. So it can really knock your temperatures back.
Yep, we lived through that for about 4 days here in Kamloops.
Yeah, for sure. So what's happening here on the big picture for the next week or so? We've got that persistent upper ridge here, these reds here just showing where we've got some fairly high heights in that upper level ridging here in Western Canada, persistent ridge where to the south it's sort of this high over low situation where we've got some a bit of an upper low there focused over western US, really quite a stagnant pattern. And sort of north and east of this upper low, we're seeing, quite a bit of unstable air. These lows can kind of fling off little upper disturbances that support showers and thunderstorms and periods of rain. So, we'll see some periods of rain in some parts of the inland Northwest here in like Oregon, Idaho. Further to the north, you may end up seeing a little bit more in the way of thunderstorm activity that has a little bit less rain. And so we still have to be concerned about the potential for lightning-triggered wildfires with this type of setup here because it's warm, but it's also unstable. And we're pumping a little bit of moisture and unstable air into this region. So we're looking out for the potential for more lightning-triggered fires in the coming days. And based on the Euro here, this is just one of their products. We can see just in the coming days here, we're certainly not out of the woods in terms of that sort of diurnal, daily, daytime heating thunderstorm activity along the mountain ridges of of Western North America. And Mike, I wanted to talk a little bit about how lightning can start fires. Let's take a look at this map. It's called Duff Moisture Code. What are we looking at here, and how does it kind of play a role in understanding how lightning can start fires?
So the Duff Moisture Code is the moisture content of the Duff layer. It's about 2 to 7 centimeters below the forest floor, and 60, the higher the number, the drier the fuel is. And 60 is very dry, and typically lightning hits a tree, often a conifer, travels down under the bark through the cambium, and then starts a fire at the base of the tree where you have lots of dry, dead needles, and it's a prime spot. And if there's rain, it can smolder and maybe for a day or two or three, and we call those holdover fires. So these can, you know, be a real problem. If it's dry, they start flaming right away and start spreading. And so everything's dry. We're getting some lightning. I expect to see lightning cause fires. We've had quite a rash. I was expecting a lot more, but the smoke really, I think, played a role. But the next couple days, next day in BC and into Alberta into Wednesday, we have to be careful because we could see a rash of fire starts.
For sure. And it's interesting because you think, well, oh, there was a whole rash of lightning that went through, but there's no fires popping up. And then 2-3 days later, suddenly, oh, there's a smoke. This is an image that I took actually in my rookie year, textbook lightning tree. If you can see in the image here, that's just that scar that electricity burned through and exploded all the bark off, hits the ground. And as Mike was saying, if you have that sort of really dry sort of the duff layer, it's semi-compacted, organic material on the forest floor there. If it's really dry, that fire can just smolder underground for a couple days, and then hot, dry, windy, and it comes back to life. Just another little story time here. This is another tree. That's me inside of a hollowed out dead poplar tree that got hit by lightning in the Grand Prairie district. And Mike, I was going to say, interestingly, with some of these lightning trees, I know there's been some research done, but it seems that a lot of times these deciduous trees, especially dead deciduous trees in a field of, like conifers that are the same height, the lightning will always find the dead poplar and hit the poplar, even if it's not any higher than the surrounding conifers. I just thought that was really interesting. I've seen that a number of times.
Yeah, that is interesting. I'm not sure why.
I've heard that it has to do with, it could be the geometry of the tree. It could also be how conductive the tree is compared to surrounding trees. But in general, yeah, it's you can see this tree's been dead for a long time because it's just hollow. There's no heartwood inside the tree. But yeah, just interesting here with this Duff Moisture Code. This is one of the many fire weather maps products that you can get on this NRCan website. Duff Moisture Code is one of them here. And we can see that in the coming days, given the warm, dry, windy weather that's expected to persist, that Duff Moisture Code's not changing at all. It takes, several millimeters of rain to really dampen that. And so we're watching over that for the next few days. In the next 10 days or so, like I say, because of that persistent upper ridge in Western Canada, we're seeing continued warm weather, much warmer than average. And if we look at the precipitation anomaly over the next 10 days as well, we're seeing that sort of footprint of that upper low to the south. Mainly convectively driven showers, thunderstorms, and periods of rain across far southern BC, southern Alberta, Saskatchewan, but across much of the rest of British Columbia and northern parts of the Prairie provinces, Manitoba and eastern Canada, remaining dry. So that's going to be a factor in really sort of prolonging the fire season as we get into later in the month, right, Mike? Because we're still seeing through for the next 30 days. Not much in the way of change. There could obviously be some variation, some cooler periods in there, but overall looking like warm and dry across much of the boreal and many of the mountain forests of British Columbia over the next 30 days. So I don't think we're quite out of the woods yet, so to speak, in terms of the fire season, right?
No, it's the usual suspects from central BC into southern Northwest Territories, northern Saskatchewan, maybe Manitoba, northwestern Ontario may flare up again. Alberta's dodged a lot of the summer fires. They were quite active in May, but with the hot, dry weather and some lightning, they could see some activity in September as well.
Absolutely. So, folks, that's what's going on with the wildfire situation across Canada at the moment. In some, we have a bunch of time for you. If you have questions, please pop them into the chat. I know there's a little bit of a lag here. I think probably about 10 seconds or so, but feel free to put your questions in the chat. I'm just going to take a look here, Mike, and see if we have any yet. Hello, Mike and Kyle. Got a lot of nice greetings. Hi, Ryan out in Vancouver, Darren in Calgary, Mark, Western Washington weather. We've got online here. Brad McMillan, West Coast weather. Nice. We got a lot of folks here. Brad McMillan says, holdovers were the worst, so hard to extinguish with how deep they managed to burn a lot of the time. And you think about like some parts of the world, Mike, you think about southern BC or like, I think of Arizona, somewhere where you have like that, the organic layer is really thin and like the bedrock is just below it. But then you go to like northern Alberta where it's like skag and peat and for several feet deep. Those fires are not easy to put out.
So yeah, there's holdovers from lightning, and that can occur in almost any kind of fuel. But the real holdovers, the overwintering fires, the ones that burn through winter, are usually in those deeper organic layers. We call peat, sphagnum mosses, and actually there's a fire that started in 2023 that's still burning in northeastern British Columbia, and that's burning through 2 winters. And given ongoing drought, it may burn right into 2026. And this is unusual for the boreal. There are places in the world like Indonesia that have peat fires that are over 30 years old, but it's a different system than our boreal forest. But that's a sign of the drought that we're seeing.
For sure. We do have a question here from Darren Howard. What are your thoughts on whether fire should be allowed to burn or whether large fire breaks should be created?
So the answer is it depends, and on the circumstances. So some fires should be allowed to burn when and where possible. We want to work with Mother Nature. And one of the first maps we showed from SIFSI, those purple, were monitored fires, and many of them are in remote areas. So, I think that's a good strategy. But, if a fire occurs close to a community or critical infrastructure, it takes half a second to say that's an unwanted fire. This concept of wanted versus unwanted fires, I think is good. But it depends on the circumstances for each fire. And I can give you some examples, like we have Wells Gray north of here. And if fire starts in Wells Gray, I often want to let it burn or monitor it. But if it starts in May, it's got all fire season to burn. I'd probably put it out, okay? If it starts in September, you look at the fire weather forecast, run fire growth models to say, where will that fire go? Is it going to threaten the community? So fire guards, yes. Around areas of high value, communities, critical infrastructure, treating fuels is one way to reduce the intensity. It may not reduce the likelihood of a fire because when you alter the fuels, especially that overstory, you're allowing more sunlight and wind to reach those surface fuels that will dry them out quicker. But the philosophy is if a fire does come, it'll be lower intensity and fire management will be able to handle it. But I will say that, it can be expensive and you want to treat areas of high value. In the States, they've been trying to treat the entire Western United States landscape. Unfortunately, that's doomed to failure because fires spread through embers being carried by the wind, and sometimes they can jump 2 kilometers, 3 kilometers. We have fire in the Okanagan 2023, the McDougall Creek fire jumped Lake Okanagan. I've never seen a fire jump Lake Okanagan. And so that's the problem with a fire break is, these fires can jump across them quite quickly, even if, the fire break has lower intensity fire in the break itself, it leapfrogs right across it and continues to burn. So it's challenging. Fire management's challenging. It's becoming more challenging as the climate changes. And I think the public expectations have increased in terms of what we can do. And there's more values on the landscape, more buildings, more critical infrastructure. My hat's off to all our firefighters. It's a tough job.
Most definitely. We got a question from Ryan Voutilainen here. Curious that we have seen An increase in dry lightning events, particularly in fall in BC, and more electric storms. Anecdotally, storms have been producing more lightning in recent years. What are your thoughts on that, Mike?
Well, there's a recent paper out that suggests most of Canada, there's no real trend in increasing lightning, though it's only a 20-year record. The exception, if I recall correctly, Bill Burrows, Bob Kochtabita published this recently. Northeastern BC, Northern Alberta are seeing more lightning. The seasonal aspects, I'd have to look back at the paper, but we are seeing more lightning on Vancouver Island in the coastal region than in the last 20 years than we've seen before. So, I don't doubt you, Ryan. I think that's something that we should explore because that's bad news. Because often our fuels are still very dry in BC in September. If we're seeing more lightning, especially more dry lightning, and for folks who may not know what dry lightning is exactly what it says. You get the lightning, but you don't get the rain. Either the rain evaporates before it reaches the ground. So it's the worst news for firefighters when you hear dry lightning.
Definitely. From Matt Grinter here, is there any new climate research on how overwintering fires will change with climate change in Canada?
Not that I'm aware of, though I can check with Dr. Shalane Haynes with the Canadian Forest Service that she did her thesis on drought. And, so we are expecting more drought in the future. So I expect overwintering fires will be more common. And perhaps we'll even start seeing them out east. Traditionally, they've been very much out west. In fact, some of the 2023 fires in Quebec may have survived into 2024. So, yeah, my expectation is with increased drought, we're going to see more overwintering fires.
That's the main factor in those overwintering fires, right? Is you have those really deep, compact organic layers that the fire can really retreat underground. Once there's drought, like in that northeastern area of BC, northern Alberta, prolonged drought, that's normally waterlogged, like soaking wet organic material. But as soon as you got the drought, it's not even necessarily due to like how short the winter, how warm the winter is, right? I mean, you're still going to be pretty cold in the winter. It's more so tied to the drought and how it dries out certain types of, the forest in certain areas of Canada. Like you certainly wouldn't expect to see any of these overwintering fires in the southern interior BC, right?
No, you need that deep organic layer. So the drought lowers the water table. I mean, many of the peat bogs are what we call hummocks and hollows. And when spring, the hollows often have water in them. But during drought, that water is not there. And when a fire goes through, actually the hollows burn more intensely than the hummocks, which is the exact opposite of what you'd think. And when you see a field of them, it's like black sheep. And that's what we call them. It's black sheep because they singe. And it's because it's a different species of peat. The ones in the hummocks have longer tubes to suck the water, whereas the hollows, because there's often water there, they have short roots and can't access that deeper water.
Yeah, for sure. We saw some incredible visuals there over that winter of 23, 24 of like folks digging down like 6, 8 feet and there's still fire smoldering underground there.
Sometimes you backhoes to get down to the smoldering.
For sure. Brad McMillan says, I remember fighting fire in the Yukon. I like how they fought fire up there. They had corridors of where they aggressively fought fire, usually around infrastructure, and the rest they let burn. Yeah, so I guess they're just going to be, any fire agency is going to be prioritizing these fires based on available resources, based on their budget, based on where the fire danger is across the territory or the province. So, I mean, I guess that's the case up there, eh, Mike?
Yeah, Yukon and Alaska is very similar. I mean, they can deviate from the plan. We call it zonation. Okay, so there's a priority zone. Fire starts, you fight it, and there's a other zone where they don't fight it, and there's kind of an in-between zone where, depending on the resources and the situation, they can fight it.
Trent says or asks, what are areas in the next 5 years that are most likely to burn up, and where is the area with the most dead trees from pine beetles?
So, I'm going to throw a curveball in here. Okay. I think the usual suspects, Western United States, Western Canada, Alaska, we're going to continue to see more fire. But I think we're starting to see more fire out east, and we saw it in 2023, and we saw a bit of it in 2025 as well. So as the climate changes, work we did about 20 years ago, 25 years ago, suggested mid-century we'd start to see Eastern Canada, Eastern North America show a lot more fire. Maybe it's coming here a bit earlier. I mean, things are moving more quickly than we thought. What was the second part of that question again?
Where are the areas where most dead trees are from pine beetles?
So, um, yeah, I'm not sure if I'm the qualified to answer that question. A lot of the pine beetle was in, central BC. There was, uh, it's been over 20 years now, and they go through stages. They go from green, which is healthy, to a red or orange, very flammable red, and because the needles are dead, but they're still on the branches and twigs. So you get fire, you get a very intense crown fire. Then you go to the silver or gray stage, the needles fall off, and it's really hard to get a crown fire because you don't have those aerial fine fuels you normally would. But you can get very intense surface fires. So we're in that, many areas are in that silver or gray stage, and there's regeneration going on finally, and there's been replanting in many of these areas as well.
Okay. Brad asks, what are your thoughts on prescribed burning, and should we be doing more or less of it?
So, yeah, yes and no. Okay. So, prescribed fire is a great tool. We don't use it enough. Okay. The the sharp edge, the double-edged sword is that we talk about good fire, we talk about bad fire, but there is no such thing as good smoke. Smoke's bad, especially in tourist areas. You don't want to be burning during tourist season, and anyone with respiratory problems doesn't want smoke. And yeah, it's a real problem, but we do so little of it. And there was a reporter, I think from Detroit Free Press, called me and said, "I'm just looking at numbers of prescribed burn in the United States versus Canada, and we're talking millions of acres in the States and like 10,000 hectares in Canada." He said, "That can't be right." I said, "Yeah, that's right." So yeah, we do very little of it. We should be doing more, minding the smoke. So burning in spring and fall, good venting days. But yeah, it's an excellent tool, but that darn smoke.
We have another one from Brad. Those overwintering fires, are there any firefighting techniques happening on those, or do they just monitor them?
No, they fight them. Okay, you can dig them up. If you have access to water, you can pump water and try and raise the water table. It's hard work. Okay, the best way is for Mother Nature to provide some more rain to raise that water table. But yeah, it depends on how deep the organic layer is, and sometimes we're talking a meter, sometimes even more, and it just takes a lot of work. It's mop up, and I'm sure you've done some of that, Kyle.
Yeah, it's no fun. Literally crawling around on your hands and knees, and I think Brad McMillan, I
Feeling
see
for
him in the
warmth.
chat there. He's done the same thing. Yeah, you're feeling for the warm spots and getting nice and dirty. You get the ash under your nails, and yeah, it's a good hard day's work out there. Thanks so much for your questions, folks. Keep them coming here for a bit. We have some more time. In the meantime, Mike, I had a couple of kind of thoughts while we're chatting here. We think about area burned in Canada, like in terms of like climate change. We think about area burned is a frequently used metric, I think, for people to say, oh, there's more area burned, so that's direct evidence of climate change. But it seems like area burned it's a complex thing, right? Because say you have like 3 or 4 really big fires that are burning in an area where we choose to just, you have a modified, or you just monitor these fires. It can kind of skew the area burned for that given year in those regions to seem like, oh, that was a really particularly bad year in terms of area burned. But it's not necessarily representative of the bigger picture. Like when I think of climate change and wildfire, I think of like we're increasing the fire weather on the landscape, right? You're lengthening your fire season, you're warming up the atmosphere, increasing evaporation potential of the atmosphere, causing lightning risk to move northward in Canada. There's lots of ways that climate change can kind of contribute to fire. What do you think about people using area burned as a metric directly to, area burns increasing in Canada, therefore we're seeing climate change? What do you think about that?
Well, I use that argument, but it is a messy variable. And we use things like area burned and number of fires because they're handy. We have those things. But it is unbiased. It's all about fire weather, and in particular, extreme fire weather. In Canada, 3% of our fires burn 97% of our area burned. Much of this happens on relatively small days of hot, dry, windy. Uh, we call them spread days, and we're seeing more spread days. So maybe that's a better indicator of climate change. And we have papers that look at extreme fire weather, and it's increasing in many parts of the globe, including British Columbia, where we've seen significant increases in fire activity since 2017. The top 5 years in British Columbia, going back to 1950, have been since 2017.
Actually have that graphic here from BC area burned. We can see there.
Yeah, the area in red far exceeds the area in green by over 1 million hectares. Uh, Top year 2023, 2018, 2017, 2024, 2021, and 2025 is not over. We may pass 1958, which was a big year until 2017. And so the top 6 years may end up being since 2017.
For sure. And Mike, while we're kind of talking about this, we had mentioned this in our sort of spring update together, but I mean, you look at like, mid 70s to late 90s or so, really. Like, I mean, when I was a kid, just anecdotally, we went on vacation in the Okanagan Valley, and there were very few smoky days when I was growing up. Really, after 2000, we started to see that increase. And I was thinking about that sort of connection between the looking at other drivers for wildfire activity, and there has also been research done, kind of looking at sort of more of those climate drivers, internal climate drivers, oscillations that we see in, say, sea surface temperatures, like the Pacific Decadal Oscillation. Like, for instance, since we're talking about it here, I did pull up a map of the sea surface temperature anomalies here, and we can see across the Pacific in this region here, the North Pacific is running a serious temperature right now. But like when we're talking about something like, say, the Pacific Decadal Oscillation, which is typically a function of what we call the Kuroshio current. It's that warm western boundary current here in the western Pacific. It's the Aleutian low. It's the persistence of ocean memory. Typically in the cold phase of the PDO, or the Pacific Decadal Oscillation, you see cooler than average temperatures along the west coast of North America. And in the past, we had a climate regime through, like I say, the 70s and the 90s, where it was the opposite. It was a warm or positive PDO, an El Nino-like type pattern. And in those years, they found that, wildfire, you saw more area burned east of the Rockies when the Pacific Decadal Oscillation was in the positive phase. Whereas when we saw that flip, that sort of regime change around the year 2000 to the negative cold PDO, the areas west of the Rockies really started to see that increase in area burned around the same time. And so, I mean, obviously, human-caused climate change is certainly a factor, but it seems like it's maybe a little bit more in the background. Like, these seem really extreme. Like, is this just noise and a sort of decadal type trend that we're seeing? Or is this, really the face of climate change that we're looking at with this rapid increase in area burned on both sides of the mountains in recent years?
Yeah, there's a paper by Mark Prigent about the abrupt increase in fire activity in British Columbia. And they point to around 2000, 2003 when things started to change. And that kind of ties in with what you were saying, Kyle.
For sure. Now, we have a couple other comments here. Trent says 2021 and 2023 were the two worst years I've been through. Smoke and seeing the fires on social media. I remember August 15th, 2021. So do I, Trent. That really put a dent in me. Hope that doesn't happen again soon. Matt Grinter asks, would you say it's not the greatest number to also use since policy change has impacted how to manage forests over time? I assume, Matt, you're talking about area burned there as well? Mike, is that how you interpreted that?
I think that's probably, but Matt can type in the chat to correct us if we're wrong.
Sure. In the meantime, sorry, go ahead, Mike.
Yeah, area burn, as I said, it's a messy variable because it depends on fire management activities. It depends on ignition, depends on the vegetation, the fuel. So yeah, it's we use it because we have it at our fingertips. And in Canada, we've seen a quadrupling of area burn since the 70s. Likewise with Western United States. If you go farther back in time, our records are less precise, less accurate, but probably in the past, many regions had more fire than what we're seeing today.
For sure. And yeah, I assume like Matt's probably like if you're saying using policy change over time, we're becoming smarter. We're realizing, oh wait a minute, putting out every single wildfire is not only prohibitively expensive, but it's not ecologically advantageous because these forests across Western Canada have adapted to burn and they need fire to reproduce in many cases, as we spoke of earlier, right? So I suppose that means that, yeah, we're probably going to let more fires burn bigger where they're not threatening those assets. That's how I interpret that question, though. And that's what you were touching on earlier there, Mike.
Yeah, and you know, allowing fires to burn more naturally, I think is the way to go. Though it does produce that smoke, and
Yeah,
we've got feedback from American Congress people about that smoke, that we're not fighting the fires. But I do point out that Western United States has also seen a quadrupling of area burned, and they are fighting the fires. So yeah, we're in the same boat, folks. And smoke from American fires does cross into Canada. Smoke knows no borders.
and when we think of sort of the human impact, we can think of human impact on climate, but also on the land, and through past philosophies for fighting fire, where the approach was generally let's put out all fires at all costs. We kind of want to avoid that where possible. Going forward into the future, just based on like we've been talking about. So we've also got here from Ryan. I attended a talk in Washington where a wildfire forestry officer discussed how fires are burning hotter, altering sold comp and resulting in expanding grasslands. Are we seeing something like this into Canada? I don't understand the sold comp there, Ryan, but I assume you're saying
Composition, soil composition.
yeah,
Anyway,
probably soil composition. Exactly. That's probably what that is there. Yeah, and we are seeing that in Canada too, right? Like if we see too many fires in a row and these forests don't regenerate the way that they should, then can we see that transition to sort of a more savanna-like landscape?
sure. Dr. Ellen Whitman's doing work in this, and we're seeing repeat fires, higher intensity fires. And if this continues to happen, our forests won't be able to regenerate. If 2023 was an average year, our fire cycles would be 25 years, and our trees won't survive. Okay, what replaces it? Grasslands or shrublands. Grasslands can burn every year. Grasslands can burn twice a year, actually. So fire won't go away. I often say there's a universal recipe for wildfire. You need three ingredients: the vegetation, we call it fuel, ignition, and weather. You get all three, you got fire. So the forest may disappear, but the fire will remain.
For sure. Yeah, that was soil composition from Ryan there. Western Washington Weather says it's very interesting how smoke season has become a common phrase and occurrence in Washington since approximately 2015 to 2017 or so, not something seen in the decades before that. I mean, that's happening here too in Canada. Smoke season. It's people are planning their vacations around that, maybe even where they live. Like, a lot of people are like, man, I would love to live in the Okanagan Valley, but smoke.
Smoke fronts now, yes. Yeah, yeah. Sorry. Yeah. If the future is, the reality is we have to learn to live with more fire and more smoke.
Absolutely. Any more questions, folks? Let's get them coming in here now. We'll probably start to wind down in a little bit, but if you have any more, please feel free to tap the wealth of knowledge that we have here. And Mike, also, I was going to ask about how can we integrate Indigenous cultural fire practices into our fire management methods and outlooks into the coming years and decades ahead.
So we have much to learn because they were living here for thousands of years in balance with fire, okay? And using cultural burns, prescribed burning, and we should be doing more of that and learning from them. They often use the phrase walking on two legs, and using indigenous knowledge with our Western knowledge hand in hand to better manage our lands. And so we need to continue that and learn more.
Definitely. Yeah, it's reading about it. I don't know very much about it, but it's really interesting to think how fire was used in a sort of advantageous way, like low intensity burns, certain times of the year when the forest isn't going to burn down, clearing out those meadows, bringing up the herbs and the berries, shrubs that, kind of attract wildlife, then you can hunt the wildlife. And it's a really sustainable way to manage fire in the landscape, I find.
Yeah, there's many reasons indigenous peoples use fire. I believe one paper listed 84 reasons why globally indigenous peoples were using fire. And, berry production, browse, agriculture. Yeah, the list goes on and on.
Absolutely. So I guess in closing here, unless we see anything else filtering in the next couple moments here, Mike, what's the takeaway here? What can people, maybe say folks living in the wildland urban interface in Western Canada or the Northwest states, what are some sort of important considerations for them?
So, fire wise, fire smart, take a look. There's principles, building materials, uh, any flammable materials within 1.5 meters of your structure or home, 5 feet for our American friends. I mean, that's the critical zone for those embers to start fires. Keep an eye in the sky, watch out for evacuations. If you see a fire, report it right away. The sooner fire management knows about the fire, the more likely they are to extinguish the unwanted ones. So, yeah, and continue to learn more about fire, and because it's going to be with us. And we also, smoke. The more we know about smoke, the more we know it's really bad for us. A recent study suggests 1.5 million people die prematurely due to wildland fire smoke.
Yeah, for sure. Make N95 masks cool again.
Yeah, I saw a lot of people wearing them on Saturday at the market. So because of the smoke.
Absolutely. Well, folks, thank you so much for joining. Really great questions there. And of course, this will be available online afterwards. Wealth of information, wealth of knowledge from Mike. Thank you so much, Mike, for your expertise as always. And we'll do more collaborations in the future. Hopefully, we didn't see too many glitches. I find this is a pretty good platform because we can talk real time, engage with folks who have questions and are living this reality. So thank you for joining, folks. I hope you enjoy it, and we will talk to you next time.